Hello everyone and welcome for DMS lecture. Today we will discuss about the design of gearbox for machine tool application where we are looking for 3 stage and 12 speed variation. So that 12 speed variation could be in 3 stages. Okay, you can look at into the diagram where the typical gearbox for machine application has been shown. So basically, a gearbox is a mechanism or a mechanical device which is used to transmit a power from prime mover to the machine with the help of a changing in a torque and speed or change in operation orientation of drive. So because of that, normally we are using this gearbox. So what is the main purpose why for using the gearbox? So main purpose to increase the torque. When the torque is developed by prime mover is less as compared to the torque required by the driven machine or a machine required. The gearbox is used to increase the torque. The increase in torque from driving shaft to driven shaft is accomplished by using this reduction in speed. So as we know that if we need the higher torque, for that we need to reduce a speed, and that could be possible only with the help of speed gearbox. Second purpose of using gearbox to convert the standard speed of prime mover to the specific speed of driven machine. In few applications, whether the prime mover runs at the standard speed, for example, 414 rpm, 1500 rpm. So these are the standard motor speed which is acting, or if you connected the gearbox with the IC engine, so it can be run with the specific speed, and the machine is required to run with another specific speed or a particular range. So at that time we are using a gearbox to use to convert the standard speed of the prime mover to the specific speed or specific speed range of the driven machine. Third purpose, to convert the single input speed to multiple output speed. In some application, as we discuss, if the specific range is required, like machine tools through a prime mover runs at single speed, the driven machine is required to run at different output speeds. In such cases, the gearbox is very useful to convert a single input speed of the prime mover to the multiple output speed of the machine tool application. Another purpose, to facilitate the specific relative positions of the machine shaft and prime mover shaft. So containing the applications need the specific relative position of the machine shaft and the prime mover shaft. In such cases, the gearbox is used to connect these two shafts. Next one, to increase the speed. In few industrial applications, the machine is operated in a very high speed as compared to the prime mover speed. The gearbox increases the speed from prime mover shaft to the machine shaft, and this increases the speed of the required machine, but in same case it reduces the torque. Okay, now these are the some purposes for which we are using a gearbox. Now If we go with the specific machine tool application, there are few different operations which we are going to perform, that is a facing, turning, milling, boring, and each every operation they require a different cutting speed, feed, depth of cut. So the variation of the speed and torque is to be changed, or you can say we have to perform a variation in the torque as well as the speed. Now that speed or variation we can achieve by using the multi-spindle gearbox. Okay, so before discussing the different type of gearbox, we will go with the few different classification. So first one, classification according to the relative position of the input and output shaft. So there are four classification. First one is a parallel axis gearbox, coaxial gearbox, intersecting axis gearbox, and non-intersecting and non-parallel axis gearbox. So these different types are depending upon the uh, arrangement of the shaft axis. Another classification according to the number of stages, single stage, multi-stage. Classification according to the speed ratio, single speed gearbox and multi-speed gearbox. In to achieve this much variation, we are using standard type of gearbox. These are sliding mesh gearbox, constant mesh gearbox, and synchro mesh gearbox. So let's go start with the basic consideration in the design of multi-speed gearbox. Okay, so first of all, the speed range between to increase increments should be 10 to 15%. A large range would be further reduced the optimum use of the tool. As the tool speed range of multiple speed driven must be divided into optimum number of the speed steps with the incrementals between 10 to 15%. Okay. Second, a number of speed ratio should be available to the operator without stopping the machine. So the speed can be changed by an operator without stopping the prime mover or electrical machine or electrical motor. Third one, the operator should able to change the speed without going through any intermediate sequences. So desired speed changes without passing through the intermediate steps, as the multiple drive should facilitate the desired speed changes without passing through all intermediate speed steps. Due to the compact system, the axial length of the gear train is least if the gear clusters are made sliding one, but the sliding gear clusters should not have more than 3 gears. Next one, only the gears which are used to achieve the gear ratio should be rotating, whereas the other gear of the gearbox should not be engaged, because the multiple speed drives, only the set of gears through which the speed is to be obtained, and that set only get to be engaged at a time. The number of shafts, gears, and operating levers should be minimum. So lesser the number of components, the machine reliability will be get um, increased or higher. The control unit should be designed ergonomically. It should be centralized and should have all possible controls at one place. So operator can be easily operate or handle any situation from a simple location, a single location. Now, determination about the variation in the speed. Now, when you consider and so first of all, what is the variation in the speed or what are the different laws can be used to decide the speed value of the different stages of the machine tool gearbox that we need to first understood. In an ideal speed range in the machine tool would be one where there would be infinite number of speed variations or speed ratios that would be allow an optimum operation of the machine by any job diameter. In such speed regulation would be called as a stepless regulation. The higher the speed variation available, higher would be the cost of the gearbox. Hence, from the cost and utility perspective, the optimum gear ratio should be available to get the different speed ranges between the maximum and minimum speed. These intermediate discrete values can be obtained by different laws. So the let n minimum and n maximum are the maximum, minimum, and maximum speed spindle speed to be achieved in z number of intermediate speed steps, and to achieve these steps we have to use a different what you can say laws of regulations. We can use these laws of regulations are nothing but or that steps can be arranged by using the following laws. Basically there are three laws: arithmetic progression law, geometrical progression law, and harmonic progression law. So each law we will discuss with a simple example. Okay, so let's start with the arithmetic progression law. In arithmetic progression, the difference between any two successive spindle is constant. Okay, so that is the main rule of the progression. As the arithmetic progression difference between two adjacent speed is constant, the various intermediate speeds should be found by using following sequence, uh, where that where we have decided small a is the difference between two adjacent speed steps, which is constant, and z is the number of steps. So the n1 is the minimum speed and nz, that is a last step, that is a maximum speed. So we have indicated n1 is equal to n minimum. Now how we can achieve the second stage? N2 is equal to N1 plus A. So it means that a constant speed variation is to be added, that is A. N2 is equal to N minimum plus A. We can convert by using first step. Now N3 is equal to N2 plus A, that is N minimum plus twice of A. Okay, so similarly up to the zth value, n minimum plus z minus 1a is equal to n max. Okay, so how we can calculate the value of a by using maximum and minimum speed and number of stages. So a is equal to n max minus n minimum divided by z minus 1. This is the difference between two adjacent speed steps, constant difference between the adjacent two steps, where the z are the number of steps. Okay, now considering any two intermediate speed variation, that is nk and nk plus 1, corresponding to the diameters that can be machined, would be as follows. So the dk upper limit in mm, dk is equal to 1000 v divided by pi into nk, and dk plus 1 is equal to 1000 into v divided by pi into nk plus 1. So this is then a dk is then a upper limit, which is in mm diameter value, and dk plus 1 is the lower diameter limit. The diameter range can be accommodated at a particular speed, which can be calculated. Delta k is equal to dk minus dk minus 1 is equal to 1000 v divided by pi into 1 upon nk minus 1 upon nk plus 1. So with this equation, you can calculate the diameter range of a particular speed. So let's see an example how we can calculate the progressions by using arithmetic progression law. Now consider a gearbox to be designed with the minimum and maximum speed of 40 rpm to 400 rpm in a 6 steps. So consider the optimum velocity for the tool would be 20 meter per minute. So they have provided the maximum speed and minimum speed, number of steps, and the velocity. Okay, so first of all, note down these values given data. Now we can calculate the constant steps value, that is a is equal to n max minus n minimum divided by z minus 1. So 400 minus 40 divided by 6 minus 1 is equal to 72 rpm. So the constant variation, or you can say the constantly you can add 72 rpm in each stage. Okay, refer the table which is shown in the right side. The diameter and the ranges with the gear ratio are to be calculated by using a tabular form. So first of all, mean speed 40 rpm. At that time, the diameter, that is a 5k, that is the gear ratio between the adjacent speeds. Okay, so next speed 40 plus 72, that is a 112. So 112 divided by 40, the speed ratio is 2.8. At that time, the diameter dk, which we can calculate with the help of previous formula. What is the formula for dk? 1000 into v divided by pi nk. Okay, so similar way you can calculate the values. Delta k also we are using referring with the help of the previous formula. So in this form, I have calculated all the variations. So first step, as we have a 6 steps. Okay, so first step speed is 40. Second step it is 112 as 40 plus 72. Okay, in third step 112 plus 72, that is 184. At that time, you can see a speed ratio for second stage is 1.64. 184 divided by 112. Okay, so in this manner you can calculate all the speed gear ratios or transmission ratios for each stage, as well as the speed variation for each stage. So the maximum speed variation which we can achieve is 400. Okay, so 40, 112, 184, 256, 328 are the number of are the speeds for stage 1, 2, 3, 4, 5, and for 6 it is 400. Okay, the speed ratio between 1 and 2 is 2.8, 2 and 3 is 1.64, 3 and 4 it is 1.4, 4 and 5 it is 1.28, and 5 and 6 it is 1.22. As you notice that the transmission ratio is gate varies. It is not constant. Okay, as you are constantly increasing a particular speed, at that time it is difficult to monitor the transmission gear ratio or a transmission ratio. So in the arithmetic progression, it is seen that at the low speed steps, more speed ranges are desired than the available. So where as a high speed steps, some of the speed ranges are available which is not necessary. So unnecessary steps are also get available over here. Okay, so arithmetic progression law you can use uh, to calculate the speed ratio, or you can say number of steps and the speed variation. Okay, next one, geometric progression. Okay, in a geometric progression the difference between two consecutive speed ranges is to be seen. Now here, okay, to understand this we will consider a simple example which is discussed in arithmetic progression, so you can understand the difference between in every law. Okay, as in arithmetic progression we have considered n1 is equal to n minimum and n2 is equal to n max. In geometrical progression we have to find out the ratios or transmit or gear ratio, you can say transmission ratio. Nt divided by n1 is equal to n3 divided by n2 is equal to n4 divided by n3, and so on. It is nz minus divided by nz is equal to psi. That is called as a geometric progression. So nz divided by n1 is equal to n max divided by n minimum is equal to phi. Phi we can again redefine, that is phi is equal to n max divided by n minimum raised to 1 upon z minus 1. Okay, so to calculate the consecutive speed range between um, each state should be a phi. So let's see an example. So same example we are considering with the maximum and minimum speed, number of stages, and the application velocity. So here the value of phi we can calculate it, n max divided by n minimum raised to 1 upon z minus 1. So phi is equal to 1.585. So here we are keeping a constant speed or gear ratio. Okay, you can say transmission ratio. So look at the table, and first step it is a 40 rpm. Speed transmission ratio should be 1.5 or 1.585. The diameters which is calculated as per the calculation. Now speed of second stage, as we are in this geometrical progression, as we are keeping the transmission ratio or gear ratio is to be constant. So 40 multiplied by 1.585 would be the speed of your second stage. Okay, so, and that is a 63.4. So similarly, in each stage you can multiply with the 1.585, you can get the another speed. So in this way, you can maintain a constant speed gear ratio. Okay, so what are the various speeds which we achieved in stage 1? 40. In stage 2, 40 multiplied by 1.585, that is 63.5. In stage 3, 63.5 multiplied by 1.585, that is 100.5. So similarly, in fourth step, it is 159.6. Fifth stage, it is 252.5. And last stage, it is a 400 RPM. Okay, so in the geometric progression, it is seen that at a low speed, still more speed ranges are desired than what is available, whereas the high speed steps, some of the speed ranges available are not necessary. Now look at for third one, that is a harmonic progression. In harmonic progression, the diameter changes between two consecutive speed ranges remain same. Considering the similar example which we have discussed in arithmetic progression and geometric progression, here the diameter is getting constant. Okay, so delta dk is equal to 100 into velocity divided by pi into 1 upon nk minus 1 upon nk plus 1, which is equal to constant. Now we have to put the value of delta dk should be constant. Okay, so the speeds how we can achieve, that is n1 is equal to n minimum, and is equal to n1 divided by 1 minus c n1, n2 is equal to n3 is equal to n2 divided by 1 minus twice of c n1. Okay, so similarly you can find out nz is equal to n minimum divided by 1 minus z minus 1 c n minimum. How we can calculate the value of c? C is equal to n max minus n minimum divided by z minus 1 n minimum into n maximum. Now variation transmission ratio psi k is equal to nk plus 1 divided by k is equal to 1 upon 1 minus c k nk. Okay, let's see with the example. Data will be same. N1 is equal to, or n minimum is equal to 40 rpm, maximum speed 6 stage, nz is equal to, or n6 is equal to 400 rpm, z is equal to 6, velocity is equal to 20 meter per second. Okay, let's see how we can calculate nk and phi k, dk and delta dk. So here we are keeping constant delta dk. First of all, you need to calculate the value of c. As we have all the values of n max and minimum and z, putting all the values in equation, what we get? C is equal to 4.5 into 10 raised to minus 3. Okay, now how can calculate nk? Nk is equal to 5k is equal to nk plus 1 divided by nk. Now for that we need to calculate nk first. At first step it is a 40 rpm. Now we need to calculate for next one. So 40 divided by 1 minus 4.5, as k is equal to 4.5, multiplied by 10 raised to minus 3. Sorry, c is equal to 4.5 into 10 raised to minus 3 multiplied by 40. So using this equation, what we get? The value of second speed is 48.78. Now let's see, find out the gear ratio. 40.78 divided by 40 is equal to 1.22. Okay, so in a similar fashion, you can find out all the variations, transmission ratios, but one thing is we need to cap delta dk should be a constant one. So speed variation, let's see, 40, 48.78, 62.5, 68.96, 142.86. Okay, how this gear ratios changes: 1.22, 1.28, 1.39, 1.643, and 2.8. Okay, so sudden variation is yet to be occurred. So what we have seen in in comparison with the arithmetic and geometrical progression series, the harmonic progression gives a better distribution of the speed in the lower speed range. At the higher speed, the values are spaced too wide apart, with the result is non-optimum use of tool. As you look at the speed variation or change in between step 5 and step 6, it gets sudden change from 142. You have to directly step on the 400 rpm, which is quite very difficult for design purpose, because it increases the dimensions and all the parameters. Okay, so let's do a simple comparison between these three laws: arithmetic progression, geometrical progression, and the harmonic progression. Okay, if we consider about the change in speed, in arithmetic progression, the constant change in speed at every stage is a constant. So change in speed in arithmetic progression is constant. In geometric progression, the gear ratio at every stage is constant. In harmonic, the diameter change in every stage is get constant. Now to calculate the variation in each stages, as we are doing this variation in arithmetic progression, we are doing the variation with the speed. So A is equal to n max minus n minimum divided by z minus 1. In geometrical, we are doing variation in gear ratio, that is equal to psi is equal to n max divided by n minimum into 1 upon z minus 1. In harmonic progression, we are doing the variation into the diameter. So here this value of C is equal to n max minus n minimum divided by z minus 1, n minimum into n max. Now to calculate the value of nk is equal to n minimum plus k minus 1 into A. So the speed variation in the speed for next step that we can calculate by using this equation. In geometrical, n minimum multiplied by 5 raised to k minus 1, and in harmonic progression, nk is equal to n minimum minus 1 minus k minus 1 c into n minimum. So these are the equations we can use to calculate the speed variation in next stage. Okay, in arithmetic progression, the lower speed zone requires much more steps for optimized machining. In geometrical progression, low speed zone better than the arithmetic progression, but still needs a few steps for optimized machining. In harmonic, the high speed zone requires much more steps to optimize the machining. Last comparison, in arithmetic progression, not based on the preferred number of series. Geometrical progression, which is based on the preferred number of series. And in harmonical progression, it is also not based on the preferred number of series. Okay. Now here few advantages of geometrical progressions which we can note it down over here. In geometrical progression, the constant loss of economic cutting speed in the whole RPM range can be achieved. Better gearbox design features can be achieved by using geometric progression law. Okay, so in this today's lecture, we have discussed the basic laws which we are using while designing the multi-stage gearbox, plus what are the basic requirements, okay, that we have discussed. We have also discussed the formulation for each law, that is arithmetic progression, geometric progression, and harmonic progression. We also discussed the difference between in each law, so that what is the major variation which can be do, and what is the output of that, okay, how it can be impact in the design. So that will be we have discussed in some point of view. In next lecture, we will discuss the remaining points, such as a selection of range ratio, selection of the gear ratio, speed ratio, progression ratio, structural formulas, structural diagrams, read diagram. What is the difference between that? How we can, what are the different rules to design gearbox layout and gearbox? Okay, so everything we will discuss in next lecture. Okay, so thank you very much for attending this lecture. I request all of you for discuss. Okay, you can re. Okay, you can. If you have any doubt, you can call me or you can WhatsApp me. Okay. So thank you very much for joining this lecture. Okay. If Thank you.